Okay, so first we're going to have a look at expanding brackets. Okay. So expanding brackets can be done in a few ways, or you see it in a few scenarios. The first scenario, which will be example 1, is if, for example, you have a term over a bracket, like so. So here you have a term x over a bracket, which is x minus 2. So to expand this out, we have to multiply the value on the outside of the bracket with each of the values inside of the brackets. So we'll multiply it by x, because that's the first term in the bracket, and we'll multiply it by 2, because that's the second term in the bracket. So what we'll have is x times x, which is x squared, and then we'll also have minus 2 times x, which is minus 2x. So now we've expanded that bracket out. Okay, now example 2, this can be a little bit more complicated. So what we can do is we can have more complex terms like this. But the process is still the same. We still multiply each term inside the bracket with the term on the outside, like so. 1, 2, 3, because now we have 3 terms in the brackets. So you can do xy times x squared, which is x cubed y, multiplied by xy times minus 2x, which is minus 2x squared y, and then 5 times xy, which is 5xy, like that. And that's our answer for that. Another way you can expand brackets, or actually let's look at factorization of the same kind. So factorization, or I should put factorizing, is the opposite process to expanding. So instead of multiplying out each term in the brackets with a single term, we take out a common term or a common value from all the terms. So if we had something like x squared plus 4x, 2x squared plus 4x, what we can do is we can take out the common factor. So for example, we know that both of these terms have a 2 in it, right? Because 4 is divisible by 2. So if we divided both by 2, we'd get x squared plus 2x, like that. And see, we brought the 2 outside of the brackets because we're taking out that common factor. Another factor they have in common is also x, because they both have an x term, so we can also take that out. But remember, you have to divide each term by x. So you get this. This is your answer. Okay, so then we have example 2, which, let's say we have 5ab plus 4a squared b, or minus 10ab squared. Okay, so this one's obviously a little bit more complicated, but we need to look at each of the terms, or each of the types of terms, and see what we can take out. So first let's have a look at the constants. So we have 5, 15, 10. So we can take 5 out of here, like that, because each of these is a multiple of 5. So 15 divided by 5 is 3, minus 10 divided by 5, which is 2, that. Another thing we can take out is a, because we have a here and a here, and we have a squared, which is also a multiple of a. So we can also take a out, like so. Obviously, if you get more confident, you don't have to, you can do it all at once. You don't have to do it step by step like I'm doing it. And finally, let's look at the b terms. We have a b term in each one. But remember, for example, we can't take b squared out because there's not a b squared in each of the other terms. So we can only take the b out, like so. So we get 1, because b divided by b is 1, and then we get 3a minus 2b. And that's our answer. Okay, nice. So, what happens when we want to start expanding more complicated brackets? So we call this expanding binomials. Like that. And this is when you have two brackets like this. X plus 2, x plus 3. So now it's not just one term on the outside, we actually have two. So it's a bit more complicated. What we need to do is we need to multiply the first term here by each of the terms, and then the second term by each of the terms, like so. So we multiply the first term, these two terms, and the second term by these two terms. If that doesn't quite make sense to you, you can use, some people like to use the FOIL method, which is first, outers, inners, and lasts. So the first would be to multiply the first two terms together. The outers would be the two outer terms, the inners would be the two inner terms, and the last would be the last terms. So you can use that if it helps. So here what we can do is now we just add all of these terms. So we get the first, so x times x, which is x squared. Let me just change the color. X squared. And then we have the outers, which is 3 times x. So we have plus 3x. The inners, which we have 2 times x. And then the lasts, which is 2 times 3. Like so. And then these two terms can be added together because they share the same they share the same variable. So we can write that as 5x. So there's our answer. Sometimes you'll see it in the form a plus b squared, like so. All this means is obviously you're multiplying a plus b by itself. So it's like this. And the process is the same from here. So we multiply the inner, or the first, then the outers, then the inners, then the lasts. You can skip this step. Once you're more confident, you can go from here to here. But yeah. Okay. Right, so we can actually do something a little bit more complicated with these. These are triple brackets. And in fact, once you know how to do 2 brackets, you can do any amount of brackets. It will be very difficult to do a lot of brackets without more tools, but this is all you'll need for your GCSEs. So let's take this fairly trivial example, or it seems like trivial, but it's actually a little bit more difficult than just expanding two brackets. So what we need to do is we have three brackets we want to multiply. So what we can do is we can multiply two of them together. We already know how to do that. In fact, we've already learned that x plus 2 times x plus 3 is x squared plus 5x plus 6. If we didn't know that, we would obviously have to use the FOIL method to find it. But yeah, we can just replace that with x squared plus 5x plus 6. The only reason I'm not doing the calculation now here is because I've already done it here. But you would do this if you're doing it. And now we have these brackets. Now this might seem a little bit more complicated, but if we remember the rule, and unfortunately FOIL doesn't work here, what we can do is we can say x, we can multiply x, the first term here, by each of the terms in the second bracket. And we can multiply the next term in the first bracket, again by each term in the second bracket, like so. And that will give us our answer. So what we do is let's multiply x by each of these. So we get, what you can think of it like is, imagine this 1 isn't here for now. We just have this x in front of this bracket. So let's multiply each term by x. So x squared times x is x cubed. 5x times x is 5x squared. And 6 times x is 6x. And now we multiply 1 by everything. We multiply everything in this bracket by 1. But because x squared times 1 is x squared, 5x times 1 is 5x, and 6 times 1 is 6, they don't actually change. Because if you multiply something by 1, it equals itself. So now we just need to simplify it. So x cubed there's no other x cubed terms, so we just keep it like that. So we have 5x squared here, and we also have x squared here, so that's a total of 6x squared. We have 6x here and 5x here, so that's 11x. And then we have plus 6, which has no other term. So we have this as our answer to this triple bracket problem. Okay. Now you might be thinking, okay, so we can expand these binomials here, but last time we learned how to factorize these binomials, but like with a single term. So you might be asking, okay, so how do we factorize something like this into this? And that's what we'll be focusing on in the next